Okay, dear. You can see my screen, am I right?
Yeah.
Okay. So tell me, don't be disappointed if I ask you a lot, but we are approaching the end of Java. So I am afraid that if we don't stress your understanding on these last points, then you will totally lose it at all because yeah, we don't have too many classes remaining for Java. So that's why I would like to make sure that you really understand or get the point from here. So first, let me try to understand from you. Do you understand what this line means here?
Um, I understand that it's making a loop and it's
Mhm.
getting all the contact names and the phone number.
Okay, so a phone list is an array list. Am I right? Is it
Yeah.
okay? And then for every time it loops, it is passing one element from the array list and putting it inside here. Am I right? Is
Yeah.
it clear?
Yeah. Yeah.
Okay. Okay. So that's why it is using he is using get name on with this contact. Am I right? So this
Yeah.
contact is what variable? I mean, it's an object or it is just a string or what?
It's an object.
Okay, perfect. With that information, then I am satisfied. We continue the remaining. Okay, so okay, let me confirm with you. Do you still remember what we said about binary search? Would you like me to just remind you of how it works?
Sure. Yeah.
Okay, so okay, you don't see now. You see. Okay, so okay, so
Oh
as
yeah, I remember this.
okay, perfect, perfect. Okay,
Yeah.
did you have a chance to write that code? Can
No,
you
I
check on your
don't
side?
think. Um, no, we didn't write the code.
So can you please write it?
Okay.
Ashvin, how is it?
Yeah. I'm writing it on my phone. Okay, I've written it already.
Okay, are you able to test it? Do you know how to test it?
Yeah. Mm, yeah, I just need to enter an array, right?
Yes.
Just any array, right?
Yes. Just note here, please, that if you don't put a sorted array, so that will, this binary search does not really work. It can only
Yeah.
work if you put it sorted.
Okay, so I need to create an array and then sort it.
Yes, so you need something like, okay, 100, 200, 300, and so on. So that is a kind of sorted array.
Yeah. 400, 500. Okay. And then, okay, so I'll use that. So then if I put,
So this returns something. You should print it out.
yeah, but I need to give it an array and a target, right?
Yes, you need to give it a target to search.
So
So
if I put the target as, let's say, 200,
mhm.
then I print out. Hmm. I have a non-static method. Binary search cannot be referenced from a static context.
So you have to add the word static here.
Yeah. Static in. Okay. Here's a 300 to I do 250 -1.
How is
Okay,
it? Is it
it's okay.
is working? Really?
Yeah.
Okay, my question to you, uh, what does it return? Does it return the index of what you are searching for, or it returns what you are searching for? So if you are searching, if the target is 200,
Yeah, it returns the index.
index, okay, okay,
And if it is in between, means I have, let's say, 100, 200, 300. And if I put 250 or 150, then it returns -1.
okay. So it means that -1 means it find it or doesn't find
Doesn't find.
it. Okay, that's clear and excellent. Okay. So now we know very well that when you pass a sorted array, it works. But we need to learn how we can sort arrays automatically. So not every time you have an array that you are able to sort it manually. So if you have a 1 million array list, you cannot really manually sort it, right? You have to find a way to make it sorted automatically. So, okay. So sorting is rearranging the values inside an array or collection in a specific order. Okay. So this is a very popular problem, fundamental problem in computer science. So there is many sorting algorithms. Some of them is fast and some of them is slow, and some consume more memory than the other. So we actually going to study at the moment in this class only one sorting algorithm. Later on, maybe we'll take another one. At the moment in this kind of course, they have 3 sorting algorithms. The way they work is totally different from each other. We have a selection sort, we have an insertion sort, we have something also called merge sort. So one of the easiest ones is actually the selection one. So they look for the smallest element and then they swap that with the first element of the array. So how we do that? We have to look here. Okay, let me see. I think practice is the key. So the first, this is the initial array. This is how it looks like. So we have here 22, 18, 12, minus 4. Now we will look at the first 3 loops, how the array will look like after each one of them. So when we first run, we will keep comparing 22 and 18. Which one is the smallest? 18 is the smallest, right? So we will keep that in our memory. So we know now 18 is the smallest. Okay, 12 is smaller or not? So 12 is smaller than 18 or not? It is. So we keep that in our mind. So minus 4 is small or not? It is small. Am I right? So we keep minus 4. So we go on until we reach the end. Okay. So what is the smallest value that we have? Is actually minus 4 so far. If you look here, there is no more minus. So minus 4 is the smallest. So we will swap. So we know that minus 4 is the smallest. So we will swap this 22 from its current position with minus 4. So minus 4 will come here like that, and 22 will go in the place of minus 4. So it will become like that. Look at here and here. Nothing else got changed. So the second time we look, so we look for this 18. So 18, we're going to search. Is it 12 is smaller? Yes, we keep 12. Okay. And we have 22. Is it 22 is smaller? No, it's not. 27 is smaller? No. 30 is smaller? No. 36 smaller? No. 50 smaller? No. 7 smaller? Yes, 7 is smaller. So we keep 7 in our mind. So 68 is not smaller. 91 not smaller. 56 not smaller. 2 is smaller. So we keep 2. And then we continue here. Nothing is smaller than 2. So it means that 18 and 2, which one is smaller?
2.
2. So we put, instead of 18, we put 2. And in the place of 2, we put 18.
Yeah.
So now compare this to this. So we managed to actually improve our list, the first 2 elements in our list. Okay, instead of 22 and 18, we are having now minus 4 and 2. Now we look to the third element, which is 7. Okay, yeah, 7 is the result, but at the end we're starting with 12. So 12, and we compare that to every element here. We find that the smallest is 7. So we swap 12 and 7. So 7 comes here, and 12 go in the place of 7, and so on. So we will keep doing that with 22 and so on until we really check every element here. Okay.
Yeah.
So of course this is something new to you, and
Yeah.
have a look at this code, please. So we do two operations that we do. Okay. These two operations, actually no, wait, no, let me say, yes, the code has two operations, but we doing three things actually. First of all, we go to every element here, and then we start to compare every element to the remaining. So it means that we need one for loop first. This one for loop will point to an element here. It will point to this at 0 index. And then once we do some code or checking, it will point to 1. And once it do some checking, it will point to 2, and so on. So this is, I mean, we know if we want to go on one by one here, we need a for loop. Okay. And then the second operation we did, which is swapping this -4 and 22. So this 22 is swapped with -4, right? So we took this 22 and we compare it to everything else here. If you want to take 22 and then compare it to 18 and then compare it and keep the lowest one. So this is also another thing that you need to do. And if you want to take something here and you want to compare it to everything else, you need also a for loop. So this is another for loop that you need. So it means that so far we have two for loops. One that take every element first, give us an element here. And so after it finish here, it will give us this. After this, it will give us this. So after we get this 22, we need another for loop to search, to take this 22 and search for everything here, which is the smallest, 18. Okay, if there is anything smaller than 18, or 12, or anything smaller than 12. So it means that we keep moving from one to another. Okay, but that does not lose our current position. Our current position here, that the main element that we are comparing to other things is 22. So it means that we need for loop that is pointing to 22, and we need another for loop that take this 22 and compare it to the others without losing our current position here. Okay, so it means that now we have two for loops. We have two operations: the biggest for loop, inner for loop. And then what about this swapping operation? So this swapping means you take this 22 and put it in the place of -4, and you take -4 and you put it in the place of 22. This swapping operation, this is the third operation that is needed. So inside your code, you will see two for loops and one swapping. So let us, I mean, the code of definitely, it's new to you, so it will look complicated, but unless we break it down to something, then we will never understand it. So now have a look. This is the first for loop here, which is responsible for the biggest, to tell us, oh, which element we need to compare it to the others. So this is J, okay? And then we have a second for loop that will take whatever we get from this position, index 0 or J, and then it will start comparing it to the other elements, okay? And then we have this last part, which is the swapping part. So if we discover that there is something that is, we said that our initial array here, that we have 22. What is pointing to us to 22 here is J. This is the J index, okay? What is, and then there is a second loop, which is this one, that will say, oh, I want to start from this position and compare every other element here in the remaining of the array with 22. So what will be doing this? This is the second for loop. So look at here, we're starting with K. So the second for loop with k, but k is j plus 1, because we cannot start comparing from here. This is already known to us. 22, we have it in our pocket. We need to compare 22 with the other elements of the array. Is that clear? I know it's not so easy at the start, but I'm trying to simplify. Am I simplifying it or am I complicating?
No, it's okay.
Really?
It's just the code itself is a bit complicated.
Yes, this is typical. The first time you see it, it's typical. So
No.
again, just I mean, if you would try to say, oh, I will just memorize, that will be hard. We try to just know that first one for loop for holding our position, second for loop for comparing. Look at this only. I just want you to see the k equal j plus 1. So if we are at the position 0, then you need to start comparing with j plus 1, means that you start to comparing from the position 1 here. If you are at 0, but if you are at 1, you need to start comparing from the position 2. That's why k is always dependent on the value of j. So where are you standing now? So it will add 1 and then start comparing. Okay. And yeah, so this an if statement. Why the if statement? It will keep comparing the element at position at minimum index, this 22. It will compare it to the other all the other elements, and then if it finds something that is smaller than our 22, then it will keep it. And it will store it in the minimum index. Okay. After this for loop finish, it will see this minimum index and compare it to j. Minimum index will carry some kind of index value, okay, and it will compare it to j value. So the j is at the moment is 0. So if it find that, and so you see here the minimum index, it start to also with j. So if you don't find anything that is smaller than 22, it means that you never changed the value of minimum index. So when you compare them, you see that, oh, they are actually if they are equal like that. So again, no, forget about it. Forget about what I'm saying. Look first. Look here. Okay. Look at this line.
Yeah.
And this line. This line is checking what?
Okay.
You put j inside minimum index. If j equals 0, equals 0, what you put in the minimum index? Minimum index will be equal 0. Excellent. Okay. Now look at this. Can you check this condition will evaluate to true or false? If j equals 0 at the moment, false. This means that in the current condition, where minimum index equals 0, they are actually equal. So this will evaluate to false, right?
Yeah.
So what is the condition that will make this evaluate to true?
If they are not equal.
Okay. Okay. Good. J will never change, because the only thing that change j is the for loop.
Yeah.
So j will always remain 0, but minimum index have a chance to get changed. Where exactly is inside here? Okay. Now let me go here. Okay, look at, tell me the index of -4. If you look at this
so
array,
it's 0.
No. So we are, our j
in the initial
0.
array, it's 3. Yeah.
It is 3, right? Here, right?
Yeah.
Okay, because we're just studying the first iteration. So okay. we know that again, let's write it here, index
Yeah.
of -4 equals 3, right?
Yeah.
Okay, so the lowest value, if at j equals 0, we have element is equal 22. And the smallest we can ever find inside our list is -4. The index of -4 is 3, right? 22 at 0, and here we have 3, sorry, -4. Oops, I need to make it. Make it bigger a little bit. 22, and here this is 3, this is 0, this is -4. Okay, and yeah, so this is the j. Now we said the j is equal 0, and we put in the minimum index equal 0 at the moment. Okay, and if we continue like that, this will evaluate to false. But okay, now you will keep looping inside and comparing 22 to the other elements. Okay, now I want you to look when we start with k equal what is in, if j equals 0 and he say 0 plus 1, it means that k equal what?
1.
1. So we will start with k equal 1. So we will start from here. This is index 1. Okay, and then we continue until the remaining ends. But never mind, I want you to let us study this specific condition. So when k equals 3, so look at here, when k equals 3 and minimum index never change, it's still 0. I want you to compare now what this if statement will result in. If element, this is the array list. This is your array element. This is everything here is elements. So the array is called elements. So at position 3, you have what?
-4, yeah.
Okay, -4. Okay. And at position 0, you have what?
22.
Okay, so now -4 is less than 22 or not?
Yeah.
It is, right?
Yeah.
So what this will do? What I'm going to insert inside minimum index? Initial value of minimum index, remember it, is 0.
Yeah.
Now, what is the value of k at the moment?
-4.
No, 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 no.
No?
No.
Oh.
Elements.
No?
Element. So okay, now okay, I understand your confusion. No, k at the moment, k is actually keep increasing. It starts from 1, and we're studying now the case where k equals 3. When k equals 3, your element.
Yeah. Okay. Makes sense.
Okay.
Is -4. Okay.
Okay. Sorry, we close. We have to close.
Okay.